What is up, Algebra 2? This is lesson 113, and we are talking about logarithms. Now, if you look in the book, we're also talking about anti-logarithms, but really, they're just calling normal numbers anti-logarithms, and when they're written in logarithmic form, we call them logarithms. Now, don't freak out by this new notation. It's really just a different way to write the exact same thing that we've already been doing. If you have a number to a power, it's going to equal another number. And you can rearrange those to write it in this way. It says log base b of a is equal to x. So that means b raised to the x power, b raised to the x power, is equal to a. So if we want to write those, it says write each into logarithmic form. Right now they're in what we call exponential form. So to write it in logarithmic form, I'm going to say log base 3 of 9 is equal to 2. What that means is 3 to this power is going to equal to this number. 3 to this power is equal to this number. 3 squared is equal to 9. 3 squared is equal to 9. And really the advantage of that is later we'll start working with these more, but you're going to have variables up here in these exponents, and we need to be able to get those out of the exponents because we don't know how to solve them right now. So it's going to give us a tool to be able to get those out of the exponents. Here is another one. This is going to be log base 10 of 1 over 100 is equal to negative 2. So again, that means 10 to the negative 2 power is equal to 1 over 100. This one here is going to be log base e of 1096.63, and technically this should be approximately equal to, is approximately equal to 7. Is equal to 1x, right? We don't really write that coefficient there. We just say, oh, it's x. Or like if we say x is really the same thing, it's x to the first power. Right? We don't write the exponent on there either if it's a 1 and it's implied. Well, when we're talking about logarithms, we call those common logs. And that's whenever the base is 10, when the base is 10. So if we had log base 10 of a, we could just write it like this. Notice there's no base written there anymore. That's because it's the common log. It's the one that we use quite often because our number system is base 10. Ask me about that later. And so we just write it without the number. So if you don't see a number there, you know it is, you're right, 10. So if I had 10 squared is equal to 100, that implies log of 100 is equal to 2, because again this base is 10, so 10 squared is equal to 100. The other one is the natural log. Is a log with base e to and 1x is another irrational number, kind of like pi. That goes on coefficient that doesn't ever repeat. Or like if we say approximately equal to 2. X is really the same thing as x to the first power. Right? We don't write the exponent on there either. It's a 1 and it's implied. Keep going on. Well, when we're talking about logarithms, without repeating, we call those common logs. So we just say 2. And that's whenever the base is 10. When the base is 10. So if I said log base 10 of a, we could just write it like this. Notice there's no base written there anymore. So use ln. That's because it's the common log. It's the one that we use quite often because our number system is base 10. But we use ln to represent natural log. And so we just write it without the number. So if you don't see a number there, you know it is 2.71. You're right, 10. The natural log of 2.71. So if I had 10 squared is equal to 100, that implies log of 100 is equal to 2, because again this base is 10. So 10 squared is equal to 100. The other one is the natural log. Is a log with base e, and e is another irrational number, kind of like pi. That goes on for infinity, that doesn't ever repeat. So e is approximately equal to 2.7182818284, etc., etc., etc. Keep going on forever without repeating. So we just say 2.718. So if I said log base e of a, we can just say the natural log of a. So use ln to represent natural log. Whoever came up with that, I think, was dyslexic or something. I don't know. But we use ln to represent natural log. So if you say e to the first power is approximately equal to 2.71, you could say the natural log of 2.71 is approximately equal to 1. So let's try a couple of these. It says evaluate each expression. So what I'm trying to find out is what does this logarithm equal? So I'm just going to go ahead and convert this back into exponential form. So what I'm going to say is I'm going to say 2. So what power is going to give me 32? And then I just have to logically figure out what that's going to equal. Well, I know 2 times 2 is equal to 4, times 2 is equal to 8, times 2 is equal to 16, times 2 is equal to 32. So notice 1, 2, 3, 4, 5. So that means this thing is going to equal to 5, because 2 to the 5th is equal to 32. 21 is very similar to this, except for notice now, instead of saying 2 to something is equal to 32, it's 1 over 32. And remember, that is dealing with a negative exponent. So now this is going to look something like 2 to what power is going to equal to 1 over 32. Well, I know 2 to the 5th gives me 32, so that means 2 to the negative 5 is going to equal to 1 over 32. Because this would be like saying 1 over 2 to the 5th. And we know 2 to the 5th is 32. So the answer to this is going to be negative 5. So those are your answers. Alright, now these next ones say use a calculator to approximate each of these. And your calculator will have a natural log or logarithmic function on there, or a common log. So for number 25, on my iPhone calculator, I'm going to say 3.7 and then hit log, and I find that this is equal to 0.568201724066995, but it just says to the nearest thousandth, so it's 3 decimal places, so I'm going to cut it right there. So I'm going to say this is approximately equal to 0.568. Some calculators you hit the log button and then the 3.7, just depends on which calculator you have. And then here for number 26, we're going to use the natural log button. So again, on my iPhone calculator, I'm going to say 1.6 and then hit the natural log, and I get this really long number. I'm just going to go ahead and round it. It's going to be 0.47. I have 0, 0, 0, so I'll just round it to there. Alright, your homework is a worksheet. Good luck, guys.